Good morning, students. Today in this linear equations in two variables, I am uploading the fourth video. Probably this is the last video what I am uploading in the chapter linear equations two variables. Much of the contents, much of the problems we have discussed already. Graphical method we have seen, and related to graph, the different problem also we have seen. Now, let us see some more problems, and I am very sure after seeing this all the four videos you are able to solve any problem from your textbook exercise 4.1 to 4.4. okay, let us start. The problem give the geometric representation of कुछ I ये 15 मिनट का okay give the geometric representation of say y is equals to minus 4 as an equation using the first question one variable and also in two variables okay, using one variable and using two variables. Give the geometric representation of y is equals to minus 4 as an equation using one variable and using two variables. Hello? कौन बात कर रहा है? ये 5 मिनट वही 3 मिनट बाद में ओके. Using one variable. Let me first explain what is the meaning of this. My children, using one variable means it is just a number line. What I will do, let me first go with using one variable. Let me draw a number line. You are quite familiar with the number line. I will take, this is the number line. Okay. I will call it as 0. This is plus 1, plus 2, plus 3, plus 4, plus 5, minus 1, minus 2, minus 3, minus 4. My children, all these must be equidistant. Yet that you will ensure all these must be equidistant. When you draw a number line, I am not differentiating which is x-axis and which is y-axis. That is, the question does not arise at all in the number line. Number line is using one variable. This number line, no need to mention whether it is x-axis or y-axis, nothing as such. Okay. Whatever, y is equals to minus 4. In this number line, I have to search where is minus 4. And the point is here. This is called as y is equals to minus 4. Y is equals to. I will tell you one thing. Don't get confused. This is x-axis. This is y-axis. The question of x-axis and y-axis arises only when it is a two variable. In the one variable, if it is asked y is equals to minus 4, this is minus 4. If it is asked x is equals to 3, you can mark here only. So there is no x-axis and y-axis in the case of one variable. Okay, the same question. Using two variables now. Using two variables, y is equals to minus 4. See, I have to draw a graph. In which y is equals to minus 4. You know that whenever you are drawing anything on a graph, there will be one point x-axis, there is one number on the y. Together we call them as a coordinate. But now I need y is equals to minus 4. That means what is the value of x? X can be any value. But compulsorily y is equals to minus 4. Come on, see here. I will first mark y is equals to minus 4. I will call this as 0, comma, minus 4. See, in this y value is minus 4. I will mark a point here. I will mark a point here. What is this point? This is minus 1, comma, 4. Minus 1, comma, minus 4. This is minus 1, comma, minus 4. I will tell you once again. I need y is equals to minus 4. X value can be anything. So, I have ensured that everywhere my y value must be minus 4. I will mark a point here. I will mark a point here and I can call it as 3, comma, minus 4. Everywhere I should ensure that value of y must be minus 4. And if I join them, you are getting a straight line graph. You are getting a straight line graph in which you can say this is for y is equals to minus 4. I will write it. This is the line for y is equals to minus 4. This is how we can solve the problem using one variable and also using two variables. Let me go for one more problem for your better understanding. Let me go for one more problem. Give a geometric representation of, I will change it. X is equals to 3 as an equation using one variable and using two variables. I have told you one variable means simply it is a number line. One variable means simply it is a number line. There is no differentiation. What is x-axis, what is y-axis, nothing as such. Okay, I will remove this. I want x is equal to 3. X is equal to 3 or y is equal to 3. Your work is to identify where is 3 is. 3 is here. I can call this is x is equals to 3. Thus, this is using one variable. Come on. No, this is not. Now I want to draw it using two variables. I want to draw it using two variables. Come on. I want x is equal to 3. I want x is equals to 3. That means what is the value of y? Y can be anything. Y can be anything, but x must be equals to 3. Can I say 3, 0? I will write some numbers. See here, 3, 0. X axis 3. Y can be anything. I can say 3, 2. X must be 3. Y can be anything. I say 3, 4. X axis 3. Y can be anything. I can say 3 minus 2. X must be 3. Y can be anything. I will represent them on the number line 3, 0. See here. 3, 0. 1 point is here. 3, 2. 3, 2. This point is here. This is 3, 2. This is 3, 0. I can choose any number, but I should ensure that x must be 3. 3, 4. 3, 4. Somewhere here. This is 3, 4. 3 minus 2. 3 minus 2. Somewhere here. 3 minus 2. This is 3 minus 2. I can choose any value, but x must be 3. If I try to join them, you are getting a straight line. And you can say this is x is equals to 3. X is equals to 3. This is using one variable, that is using two variables. Let me go for the last problem. I will change it now. Let me write 2x minus 7 is equals to 0. See, I have given the equation slightly different form. 2x minus 7 is equals to 0 as an equation using one variable and using two variables. What I will do? See, in my earlier case, it was simple. X is equals to 3. I have marked here. In my previous case, x is equals to y is equals to minus 4. I have marked here. Now it is slightly different. Okay. What I will do? 2x minus 7 is equals to 0. I will transfer the minus 7 to that side. 2x is equals to plus 7. Therefore, x is equal to 7 by 2, nothing but 3.5. My work is to identify 3.5 on the number line. Plus 3.5. Plus 3.5. 3.5 lies between 3 and 4. It lies between 3 and 4. This is 3. This is 4. Somewhere here is the point 3.5. You can say it is x is equals to 3.5. This is how you are representing on a number line using one variable. Now how to represent using the two variable? Same thing. What you are doing? What you are doing is x value must be 3.5. Y value can be anything. X value must be 3.5. Y can be anything. Can I say the values are 3.5 is the value of x, y is 0? I can say x is equals to 3.5, y is equals to 2. X is known to us 3.5. That must be the value of x. Y can be any value. I can say 3.5. Y is equals to I can say 4. Let me represent these on the number line. 3.5, 0. See, this is x-axis. X-axis 3.5. Y-axis 0. That means this is the point 3.5, 0. 3.5, 2. X-axis 3.5. Y-axis 2. Y-axis 2. X-axis 3.5. Somewhere this is the point 3.5, 2. I have one more point 3.5, 4. 3.5 is the value of x and the value of y is 4. Value of y is 4. This is 3.5, 4. And when you try to join these using a straight line, when you try to join these using a number line, you are getting a straight line. You are getting a straight line. Okay? And on this you can say 2x minus 7 is equals to 0. This is the straight line. Okay? This is how we can represent on a number line using one variable as well as using the two variable. Let me go for one more and the last problem. I can say 2y plus, or I can say plus 9 is equals to 0. 2y plus 9 is equals to 0 is my next question. What I will do? I have told you repeatedly, I am telling, when it is a one variable question, just a number line. Just a number line. Whether it is, no need to think whether it is x-axis or y-axis, because the question does not arise whether it is x-axis or y-axis when it is a one variable. Just remember this to solve. 2y plus 9 is equals to 0. 2y is equals to minus 9. Therefore, y is equals to minus 9 by 2. Answer is minus 4.5. Where is minus 4.5? On the number line, you have to represent minus 4.5. This is minus 4. And here is minus 5. In between minus 4 and minus 5, there is a point. We can say y is equals to minus 4.5. Y is equals to minus 4.5. Okay. Coming to the two variable. Y value is fixed. X can be anything. Y value is fixed. X can be anything. I can say x-axis 0, y value minus 4.5. Y value is fixed, my dear children. Y value is fixed. I can say 1, minus 4.5. 3, minus 4.5. Because we know the y value. X can be anything. X can be anything. One more if you want. Say minus 2, minus 4.5. I can change the value of x, whereas y must be fixed. Come on, let me try these coordinates on a graph paper. Come on. 0, x-axis 0, y-axis minus 4.5. X-axis 0 is here. Y-axis minus 4.5 1, x-axis 1, y-axis minus 4.5. This is the point. 1 comma minus 4.5. Come on. 3 comma minus 4.5. X-axis 3. Y-axis minus 4.5. This is here. Minus 2 comma minus 4.5. Minus 2 x-axis is here. Y-axis minus 4.5. It is somewhere here. And when you try to join them, definitely you are getting a straight line graph. You are getting a straight line graph. And on this graph you can write 2y plus 9 is equals to 0. This is how you can represent geometrically a given equation. You can represent geometrically using one variable and using two variables. This is how you can solve the problems of exercise 4.4 from your textbook. This is another problem. Problem looks to be a little lengthy. Let us try to understand the problem first. Then we can start solving. Work done by a body with constant force is proportional to distance travelled. They say work done is equals to force into distance travelled. This is the formula what they do. Say have given work done by a body with a constant force is proportional to distance. Actually, how we can write? See, work done is proportional to, listen carefully, the work done with a constant force. This constant force I will not take for the time being. The work done is proportional to distance travelled. See, in physics we are going to study all these things. When we remove this proportionality and make it as equal, there will be one constant. That constant is the force. I will write again like this. Work done is equals to some constant I have write here. That constant is a force. I can say force into distance travelled. This is the formula given to you in this problem. Work done is equals to force into distance travelled. And they say form an equation using two variables. See, now you may say that there are three different variables. Work done is there, force is there, distance is there. But they made it point clear. Draw a graph by taking the constant force as 5 units. This force is fixed now. This is fixed. So you take this as y and this as x. I will write. Let work done be y and distance travelled be x. This I will take it as y. This I will take it as x. Now the equation is, therefore the equation is y is equals to, what about this force? They have given force is a constant, how much? 5. It is 5 into x. This is the equation. Form the equation in two variables. And draw a graph. To draw the graph, what I need? To draw the graph, I need values. So I will go for a table. Let me prepare one table for this. Okay, different values for x. I will get different values for y. X and y. I will take x is equals to 1. Very simple. X is equals to 1. 5 ones are 5. That is the value of y. Y is equals to 5. I will take x is equals to 2. X is equals to 2. X is equals to 2. Y is equal to 5 2s are 10. 5 2s are 10. I will take x is equals to 3. X is equals to 3. 5 is 15 is the value of y. X3, y 15. Now how to represent on a graph? What I will do? On the x-axis, let me take 1, 2, 3 as it is. But on the y-axis, I will change it now. And I will write it as 5, 10, 15, 20, 25. I will write like this. This is minus 5, minus 10, minus 15 and so on. I will take here 5, 5 1 unit is equals to 1 centimeter. Okay, let me mark now. Come on, I will mark now. 1 5, x-axis 1, y-axis 5. This is somewhere here. X is equals to 1, y is equals to 5. X is equals to 2, x is equals to 2, y is equals to 10. This is somewhere here. X is equals to 3, x is equals to 3, y is equals to 15. This is somewhere here. When you try to join this, definitely you should get a straight line graph. You have to get a straight line graph, and this is the straight line graph what you are going to get. Let me extend it. I will extend it. Okay, this is the straight line graph for what? Equation y is equals to 5x. Y is equals to 5x. That's all. Now I will teach you how to read the graph. How to read the graph. This is also very, very important. Now somebody asks you, by reading the graph, my children, let me make the point clear for you. X-axis, x-axis, this is the x-axis. This is x-axis, nothing but distance traveled. This is the distance traveled. And this is the y-axis, nothing but work done. This is work done. Now the question is asked to you, by reading the graph, listen very carefully, by reading the graph, you tell me what is the distance traveled for 25 units if the work done is 25. The question is, if work done is 25, what is the distance traveled? I will write the question here. If work done is 25 units, find distance traveled using graph. If work done is 25, what I have to do? I have to draw work done is 25. From 25, I have to draw a perpendicular line to y-axis. Then from there what I will do? From here, I will draw a perpendicular to x-axis. Where it will touch? It will touch, say 5. I can say the answer. Distance traveled is equals to 5 units. This is how we can read the graph. Now, if they ask you, find the work done. Find the work done. If the distance traveled is 10 units. Distance traveled is 10 units. What is given? Distance traveled is given. Find the work done. How much is the distance traveled? Distance traveled is not 10 units, it is 2 units. Find the work done if the distance traveled is 2 units. Distance traveled is 2 units is here. Distance traveled is 2 units here. What is the work done? Work done is 10 units. Work done is 10 units. Answer is work done is 10 units. This is how we can read the graph. After this, we are going for a last problem. This last problem is related to measuring the temperature of a body. See, you know that to measure the temperature of a body, we have two different units. It is measured in the Fahrenheit or it is measured in degrees Celsius. Okay. Usually in India, we measure the temperature in degrees Celsius, whereas in the foreign country we are using in the foreign country they use the unit as degree Fahrenheit. And based on this, there is a problem. We will discuss it. The conversion factor of degree Fahrenheit to degree Celsius is as below. Is as below. Fahrenheit and Celsius both are the degrees to measure the temperature, and the conversion factor is F is equals to 9 by 5 C plus 32. This is the conversion factor. Okay. Here, whenever you are putting the Celsius value, you are getting the Fahrenheit. They say draw a graph by taking degree Fahrenheit on y-axis and degree Celsius on x-axis. Okay. That means the equation what happens now? Take Fahrenheit on y-axis means is y is equals to 9 by 5 into x plus 32 is the equation. Fahrenheit represented by y, Celsius is represented by x. That's what they are telling. Degree Celsius on x-axis, degree Celsius on x-axis, and degree Fahrenheit on y-axis, degree Fahrenheit on y-axis. Okay. Now equation becomes like this. I will write y is equals to 9 by 5 into x plus 32. Okay. But keep in mind, this is degree Fahrenheit. This is degree Fahrenheit and this is degree Celsius. Okay. Now let me put different values. I will write here. This is x-axis means degree Celsius. This is y-axis means degree Fahrenheit. I will give different values for x. You are getting different values for y. I will give such a values where easily it is getting cancelled. I will put x is equals to 5. X is equals to 5. What happens? 5 gets cancelled. 5 gets cancelled. It is 9 plus 32 gives you 41. Gives you 40. Come on. I will put x is equals to 10. I will put x is equals to 10. 10, 5 ones are 5 twos are. 5 ones are 5 twos are. It is 18. 18 plus 32 gives you 50. Gives you 50. I will put x is equals to minus 5. X is equals to minus 5. I will substitute here x is equals to minus 5 for the time being. Okay, it is ones are minus 1. Minus 1 into 9, minus 9. Minus 9 plus 32. 32 minus 9. Is it 23? 23? Which sign? When one plus and one minus is there, bigger number minus smaller number, subtract, give the sign of the bigger number is plus 23. It is plus 23. Can I give x is equals to minus 10? Can I give x is equals to minus 10? Come on. X is equals to minus 10. What happens? 5 ones are 5 twos are. 5 ones are 5 twos are. It is minus 18. Minus 2 into 8 minus 18. 32 minus 18. Watch. 32 minus 18. Is it 14? Is it 14? Subtraction. Which sign? 1 plus 1 minus. 1 plus and minus. Subtract. Give the sign of the bigger number plus 1. Yes. Let me represent this on a graph paper. Let me represent this on a graph paper. Okay? Okay, come on. This is x-axis. This is y-axis. Let me substitute. So these are multiples of 5. So let me write here 0. This is plus 5, plus 10, plus 15. I can write minus 5, minus 10, minus 15. My dear children, this distance should be uniform. Okay. But here I will take this is 10, this is 20, this is 30, this is 40, this is 50. Okay? Come on, let me start. 5, 41. X-axis 5, X-axis 5, Y-axis 41. 41 means in between 40 to 50, 10 are there. The first line itself is 41. This line itself is 41. This line itself is 41. This is the point 5, 41. 10, 50. This is 10. 10, 50. Somewhere here 10, 50. Minus 5, 23. Minus 5 is here. 23 is here. 20, 21, 22, 23. Somewhere here it is 23. Okay, this point is minus 5, 23. Minus 10, 14. Minus 10, 14. 14 means 11, 12, 13, 14. 14 is here. Minus 10 is here. Somewhere this is the point. Okay. When you try to join, definitely it must be a straight line graph. It must be a straight line graph. Okay, it must be a straight line graph, and this is the equation for f is equals to 9 by 5 c plus 32. You can give a scale here. Now the scale is different. On x-axis difference is 5, on y-axis difference is 10. So you have to mention separately. On x-axis 1 centimeter is equals to 5 units. 1 centimeter is equals to 5 units, and on y-axis 1 centimeter is equals to 10 units. This is how the problem can be solved. From the graph, find first question. Find degree Fahrenheit when temperature is 15 degrees Celsius. When the temperature is 15 degrees Celsius, what is the degree Fahrenheit? Second, if temperature is 0 degrees Celsius, find degree Fahrenheit. Two questions. Third question they ask, if temperature is minus 15 degrees Celsius, find degree Fahrenheit. Third question. And the fourth question they ask, find the temperature for which numerical value of degree Fahrenheit and degree Celsius are same. Let me explain you one by one. Find degree Fahrenheit when temperature is 15 degrees Celsius. They are asking you from the graph you have to find. If temperature is 15 degrees Celsius, what is the degree Fahrenheit? Very simple. See what I will do. This is degree Celsius. If temperature is 15 degree, find the degree Fahrenheit. Fahrenheit is here. What I will do? 15 from 15 degree, I will just go on drawing a perpendicular to x-axis. Perpendicular to x-axis. And let me produce this. Let me produce this somewhere here. I will start from here 15 degree. Go on drawing a perpendicular line up to where? Up to where the line intersects, touches. From there, what I will do? I will draw a perpendicular to y 15 degree Celsius. It is approximately, see, 51, 52, 53, 54, 55, 56, 57, 58, around 59 degree. You can find it very easily on your graph paper, around 59. Let me check whether my answer is correct or not. What I will do, I will check here. I will put degree Celsius 15 degree. Come on. It is 9 by 5 into degree Celsius 15 degree. 15 degree plus 32. 5 ones are 5 threes are 9 threes are 27. 27 plus 32. It is a 59 degree Fahrenheit. My answer is right. My answer is right. Second, if the temperature is 0 degree Celsius, 5 degree Fahrenheit. This is the temperature in degree Celsius, 0 degree. For that, what is the value in Fahrenheit? It is somewhere touches here. After this is 39, 30, 31, around 32 it is. It is 32. I can say the answer like this. Answer for my first question. If temperature is 15 degrees Celsius, then temperature in degree Fahrenheit is 59 degree Fahrenheit. Second answer. If temperature is 0 degree Celsius, if temperature is 0 degree Celsius, then temperature in degree Fahrenheit is how much? 32. It is 32 degree Fahrenheit. Let me check whether I am correct or not. I will check it here only. How much? Temperature 0 degree Celsius. 9 by 5 into 0 degree Celsius. 0 degree plus 32. So this entire portion is 0. 0 into anything, answer is 0. Plus 32. Answer is 32 degree Fahrenheit. That is the answer for my second question. I am right. Coming to the third question. If the temperature is minus 15 degree, if the temperature is minus 15 degree Celsius, this is minus 15 degree Celsius. What is the temperature in the Fahrenheit? I should go up here and draw a line here. This is around 1, 2, 3, 4, 5. 5 or 6. 5 or 6. You can find it very easily on your graph paper. Very clearly you can find the graph. Let me check here. F is equals to 9 by 5 into C plus 32. My question is temperature is minus 15 degree. Temperature is minus 15. 9 by 5 into minus 15 degree plus 32. One's up, minus 3. It is minus 27 plus 32. Minus 27 plus 32. 32 minus 27 is 5 degree. So answer is right. 5 degree Fahrenheit. I have told you 1, 2, 3, 4, 5. 5 degree Fahrenheit. This is the corresponding value for minus 15 degrees Celsius. Third answer I can write. I can write in a simpler way also. Minus 15 degrees Celsius is equals to, I can write in the centers form also, or simply I can write minus 15 degrees Celsius is equals to 5 degree Fahrenheit. 5 degree Fahrenheit. Okay. My last question. Find the temperature for which numerical value of degree Fahrenheit and degree Celsius both are same. See, my dear student, what we have noticed so far? 15 degrees Celsius, this is 59 degree, this is 0 degree, this is 32 degree, this is 15 degree, minus 15 degree, this is 5 degree. That means every Fahrenheit value is different, Celsius value is different. Celsius is 0, Fahrenheit is 32, both are not same. This is 15 degree, that is 59 degree, both both are same. They are asking you, is there any a common value which is the same for degree Celsius also? Degree Fahrenheit. That means degree Celsius and degree Fahrenheit both must be same for a particular degree. Is there such values? Yes. I can say minus 40 degrees Celsius is equal, this is the answer for the first question. Minus 40 degrees Celsius is equals to minus 40 degrees Fahrenheit. But that is the only case where degree Celsius and degree Fahrenheit both are same. Let me confirm it first. I will show you applying the formula. F is equals to 9 by 5 C plus 32. Okay? I have to show for a particular degree, value of Celsius, value of Fahrenheit both must be same. Come on. I have chosen minus 40 degree. I will write here 9 by 5 into Celsius minus 40 plus 32. I should get the answer also minus 40 only. I should get the answer also minus 40 only. Come on. 5 ones are 5 eights are. With a minus sign, my dear. With a minus sign it is. So 9 eights are 72. Minus 72 plus 32. Minus 72 plus 32. Answer is 32. 72, 32. Minus and a plus. Bigger number minus smaller number. Answer is 40. Give the sign of the bigger number. This is the answer in Fahrenheit. So I can say minus 40 degrees Celsius is equals to minus 40 degree Fahrenheit. This is the only value in which what?